Now before we solve a system using the inverse matrix, I actually want to go back to this page. Looking at this matrix that we were given and this typo that I had on here, I had a -6 there. What if that would have been a +6 and I said find the inverse matrix? Well, let's just find it on the calculator really fast. We'll go to edit. It's a 2 by 2, 3, 6, 1, 2. Quit the screen. We're going to do matrix. I want matrix A and I want to find the inverse. I get this. So what does that mean? That means this is a singular matrix. It doesn't have an inverse. If you get this on your calculator, this matrix would not have an inverse. Okay, so be careful with those as well. Now, solve a system of equations using the inverse matrix. This is just the generic form of two linear equations in a system. Remember, your A, your B, and your C, those are just numbers. X and Y are your variables. So what you want to do is set up your coefficient matrix, which is pretty much what we've been doing, except before we augmented it. So you'll see we have our coefficients, A, B, A, B. This is your coefficient matrix. Then you have your variable matrix. Your variable matrix represents your X and your Y. Then you have your constant matrix. Remember, these are just numbers. Those represent your constants. So if you were to multiply this out in equation form, you would have your coefficient matrix times your variable matrix is equal to your constant matrix. You can double check this. If you multiply that out, it should end up looking just like that. Let's see. That's A1x plus B1y equals C1. A1x plus B1y equals C1. Then we have the other one. A2x plus B2y equals C2. A2x plus B2y equals C2. So you can see how this equation is the same thing as the equation we had at the beginning. Well, if I wanted to solve this matrix equation for the variable matrix, wouldn't I divide by this matrix? Well, that's the same thing. What if we call this A, right? What if I multiply this side by A inverse and I multiply this side by A inverse? If we do that, these two will cancel out. I'm left with this matrix is equal to whatever I get when I multiply these two. Alright, so we're doing the same math that we've always done. We're just adding an extra level to it. So let's say that we're given this system of equations. First of all, what is your coefficient matrix? That's going to be 3, 8, 4, 11. Your variable matrix is the matrix XY. And then your constant matrix is the matrix 5, 7. Before you can solve this, actually, let me go ahead and write it out. I'm going to leave a little space in here. So if we wrote out our matrix equation, it would look like this. Of course, normally there's no space right here, but I know that I need a space. So I left that in there so we can add the inverse matrix in there. Let's use our calculator to find A inverse. Matrix, edit. This is a 2 by 2. 3, 8, 4, 11. Quit the screen. Recall matrix A. Find the inverse. And we get 11, -8, -4, 3. To solve this matrix equation, you multiply both sides by the inverse matrix. So you're actually going to multiply for 3 on both sides. Now remember, the placement is important. It needs to go in front of both sides. Well, if you were to multiply, I just want to show you on the calculator what really happens. I'm going to store this in matrix B. So let me make a little note. I stored this in matrix B. Okay, so if I multiply B times A, matrix B times matrix A, I get the identity matrix. And if I multiply the identity times xy, let me just do that. If I multiply these two, I get the identity matrix. And then I multiply that by, oops, don't put that line there, xy. Now let's multiply the right hand side. I'm just going to use the calculator to do all this just to save some time. So this is B, and I don't have this one in there anywhere, and that's also not a fraction. Okay, so clear screen, matrix. This time I'm going to go to C. That is not what I wanted to do. Matrix, edit, C. This is a 2 by 1. This is 5, 7. 5, 7. Quit the screen. So what I did was store this one in C. So I'm multiplying B times C. Second matrix B, second matrix C, and what do I get? I get the matrix -1, 1. When I multiply 0, 1, 0, 0, 1 times xy, I just get xy equals -1, 1. Well, that tells me that x is -1 and y is 1. So you just solved this system of equations our 5th way, and that is using inverse matrices.